Hi everyone and welcome to Backer Breaks It Down. Today we're going to look at similarity and right triangles. Now, I know what you're thinking. You're thinking we've worked with similar triangles before and sometimes they were right triangles, but these are different. Okay, because I'm talking specifically about well, I'm talking specifically about a right triangle that's been split into two similar right triangles. But why are these triangles similar? So we took a look at an animation in class that proved that these three triangles in this diagram here are similar to each other basically by angle. Okay. And so what we saw in that animation was the right triangle altitude similarity theorem that says if an altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. So in this diagram here, this altitude they speak of is the segment CD. And the hypotenuse they're referring to is AB. So when you have an altitude drawn to a hypotenuse, these two triangles are created, and all three triangles are similar to one another. And so we investigated what the relationship, got a little head there, with their sides was. Okay, so I posed this problem to you guys in class, and we filled out this table identifying the short leg, the long leg, and the hypotenuse of each of the three similar right triangles. And I challenged you to find the lengths of x, y, and h. Okay, h being the altitude, x and y being the two segments of the hypotenuse. And so this is what you all came up with in class. All right. So you ultimately, to get a, you created a proportion to find the value of x, which was like the segment adjacent to leg AB. So like this one right here. Okay. And basically like the table allowed us to see that like we could create a proportion with like 5 over x and 13 over 5. That was the proportion that you all created. So you created this proportion between the short legs and the hypotenuse of triangles ABC and ADB. Another proportion that you all came up with, because I asked you, hey, what would you do to like find y? Just like undoing all this, sorry about that. And for y, because here's why, you guys came up with this. So you're like, you saw this relationship. So 12 over y equals 13 over 12. So once again, you came up with a relationship relating a leg to the hypotenuse using the segment adjacent to the leg. Okay, and so that would be these here. Okay, so both of these proportions is relating the hypotenuse of the main right triangle, a leg of the main right triangle, and the segment adjacent to the leg. And so what this is illustrating is the right triangle altitude leg theorem. So if the altitude is drawn to the hypotenuse of a right triangle, each leg of the right triangle is the geometric mean of the hypotenuse and the segment of the hypotenuse adjacent to the leg. Okay. And so going back to these proportions that you all created in our investigation, like A and B. I'll see. A is a leg, B is a leg. And they said it's the geometric mean between the segment adjacent. So X is the segment adjacent, Y is the segment adjacent. See, so here's leg A, segment adjacent is X. Here's leg B, segment adjacent is Y. Okay, and then you also have the hypotenuse of the main triangle. When it came to that third proportion you created to find H, that altitude, I asked you, is there another way? Because if you look at this, ultimately they're relating the altitude H to all three sides of the original right triangle, A, B, and C. So that's like 4 known values, all different, okay? So is there another way we can find H that doesn't involve me like having to work with like 4 quantities, okay? And so like what we discovered looking at this table that we created is right here, you'll notice that we have another proportion that looks like this. So X over H equals H over Y. Let me take that out for you. And so H is our altitude, and X and Y are the segments of the hypotenuse. So here we have a relationship between the altitude and the segments of the hypotenuse. So this is the right triangle altitude hypotenuse theorem. And the right triangle altitude hypotenuse theorem says that the measure of the altitude drawn from the vertex of the original right triangle is the geometric mean between the measures of the 2 segments of the hypotenuse. Or simply put, X over H equals H over Y. H is your altitude. X and Y are those 2 segments. Okay. So our investigation led us to all these relationships, which I have summarized right here. Okay. Like I would highly advise labeling a diagram. So leg A, leg B, the original hypotenuse is C, the altitude is H. A and X, they go together. So you got leg and segment. And then B and Y go together, leg and segment. Like label your triangles like this. And then determine which of these relationships is going to help you find that missing length. Okay. Perhaps you're using the altitude hypotenuse theorem, where you're relating the altitude of the triangle to the segments of the hypotenuse. Perhaps you're using an altitude leg relationship, where the leg squared is the hypotenuse times the adjacent segment. It's totally possible that you just like work with Pythagorean theorem still, because there are 3 right triangles in this diagram. And then of course, don't ever ignore the fact that X plus Y equals C. Let me just highlight that for you. So X, and then here's Y. But notice that like the 2 of them, when you put them together, you get side C. So if you know any 2 of those 3, X, Y, and C, you can find that third one. Okay. So let's try a basic problem where we're finding some missing segments. Number 3 is not one of those basic problems, so I'm going to save that one for our in-person class time. So I'm going to go to number 4. Okay. Now, notice that they're using the variables U, V, and W. And when I label my diagram, I don't use those. And like, honestly, relabel the diagram. Just pay attention to, the original variables, but like relabel your diagram A, B, C, X, Y, H, right? So you have like leg A, leg B, the hypotenuse is C. A and X go together, B and Y go together, and the altitude is H. Okay, so let me highlight what we know. So we know H is 9, and we know 3 is Y. And we have to find everything else. Like we have to find A, we have to find B, we have to find X, okay? But we know H and Y. And so if you consider all your relationships here, we know H and Y. So it kind of makes sense for us to start with this relationship, that the altitude squared is equal to the segments of the hypotenuse multiplied together. I'm going to start with that. So H squared equals X times Y. And now I'm going to use like the variables and values from this problem. So H has a value of 9. What we call X, they're calling U. So I'm going to bring their variable in. And Y is equal to 3. So we have 9 squared equals U times 3. So that means 81 is equal to 3 times U. And that means that U has a value of 27. Okay. So that's 1 variable down, 2 more to go. Now I want you to realize, now that we know that U is 27, there is now more that we know in this diagram. Let me highlight this for us. So if I know that U is 27, I now know what C is. Because remember, C is what we call X and then plus Y. So that means C is going to be 27 plus 3. So C is 30. So that gives me something new that I have available to work with. And that's really going to help me find A and B. Okay. Because if you look at the formulas above, like A squared equals C times X. I know C and I know X. So now I can very easily find A squared. So A squared equals C times X. There, what I call A, they're calling W. So I'm going to bring in their variable. The value of C is 30 and X is 27. So I get that W squared is 810. Do you know what I see when I look at that? I see 81 times 10. So that means W is going to be like 9 square root of 10. And then in order to find what we call B, B squared is C times Y. I know C, I know Y. So I can very easily find what I call B squared. So I call it B. The problem calls it B. So V squared equals C, which is 30, times Y, which is 3. So that's 90. And if I take the square root and simplify, that's 9 times 10, so 3 root 10. Okay. So like the key to like finding these missing sides and segment links is really label the diagram A, B, C, X, Y, H, and then just determine which like of those formulas up above, which one is the best one to start with, that you know 2 of the 3 things. So start with that one, and that's what we did. Okay. But definitely start with labeling that diagram so you can figure out which of these formulas to use. So the altitude squared is equal to the segments of the hypotenuse multiplied together. The leg squared is equal to the hypotenuse times the adjacent segment. Keeping in mind the two segments x and y together add up to be the original hypotenuse C. And then, of course, that you can always use the Pythagorean theorem if you know two of the three sides of a right triangle. And that's how Backer breaks it down.